Hello, welcome to Cetra's Engineering Lab. My name is Gino Pinto. I'm a manager of R&D here at Cetra, and I'm here to talk to you about high overpressure capability on pressure transducers. Behind me, you will see there are 3 pressure transducers installed in a manifold. I'll be giving a demonstration of overpressure capability. 2 of these transducers have high overpressure protection, and one of them is a typical transducer that does not. So you will see the benefit of this feature. And there are some products on the market like this high line pressure, low differential pressure transmitter that offer high overpressure capability. But as you can see, this is a very bulky product, and in many applications it cannot be installed in equipment where a size of a smaller product with a more cost-effective solution might be beneficial to that application. So I'm going to give this demonstration. This unit is a differential pressure transducer. You can see there's a reference port on there. This one is a gauge pressure transducer, 0 to 15 psi. This one is a gauge pressure transducer to 25 psi-G. The differential one is the lowest range. It's 10 inches of water column, roughly 0.36 psi. So I have the manifold attached to a pressure controller, and the output of each transducer is being recorded on this strip chart. You can see there's the blue line, green line, and yellow line from these transducers, and there's a meter with a blue indication, green indication, and yellow corresponding to these transducers. These are reading very low values. We have 0. I have another digital gauge here showing 0 pressure. Control is having vented 0 pressure. You can see milli-inches of water, milli-psi, negligible pressure in the manifold right now. So I am going to enter a pressure of 0.36 psi, which is equivalent to about 10 inches of water. And you will see the blue trace from the differential pressure transducer coming up to pressure. It's trying to stabilize. Pressure controller is overshooting a little bit. It's stabilizing now at 10 inches of water. You can see the meter reading 10 inches. I'm going to now change this to 15 psi. And now you can see the pressure's rising. The differential pressure transducer, it's already clamped at 11 inches. That's the most pressure it's going to record. The output is clamped. But the pressure is continuing to be recorded now by the 15 psi unit. You can see it's starting to stabilize at 15, and there it is, 15 psi. This other unit that's at 25 psi, it had already been overpressured, and you can see it's falsely recording 26.8 psi on the meter when in actuality it's only 15 psi. So I'm going to vent this system now, and we will see the pressure is going to drop back down to 0. It's takes a little bit of time to get the pressure out of the manifold. You can see it's decaying from this green line, and now the blue, the low differential, is starting to decay and come back to 0. It's nearly vented now. You can see what milli-inches of water. It's essentially 0. Now I'm going to subject this to a high overpressure condition. I'm going to detach it from our pressure controller because it cannot generate very high pressure with it the way it's configured right now. I'm going to attach a simple hand pump to the manifold, and I'm going to pump and apply pressure. You can see the digital gauge is now recording the pressure. It's about 12 psi. I'm already saturating this transducer, and you can see this one is recording 12 psi as the gauge, and now I'm over 15, so that one's saturated. And again, this one was falsely recording pressure because it had already been overpressured in a previous test. So I'm going to bring this manifold pressure as high as I can get it within the limits of this digital pressure gauge, which is basically 200 psi range. So I'm at 200 psi. All of these units have been are now highly overpressured. This one over 500 times its full-scale rating. This one over 13 times its full-scale rating. This one about eight times its full-scale rating. Where again, it's proof pressure. Proof pressure is the maximum pressure that you can subject the device to without it needing to be recalibrated. So it's not significantly affecting its accuracy. Where a proof pressure rating on this typical transducer may be 2 times its full scale or 3 times at best its full scale. These offer much higher proof pressure ratings. Vent it. Now we're returning to 0. Very easy to check. The manifold is vented. The low differential pressure transducer is reporting in the milli-inches of water. So it very negligible effect on the 0. Same with the 15 psi-G, that's reporting 60 milli psi. Again, it's recovering pretty good back to 0 where it started. This one had already been proofed, and it looks like it just continued to go in that same direction. It's closer to 13 psi now. So let's check what happens when we apply the full-scale pressure. Let's start with the 10 inches, which is 3.6. So it's pretty close now. As you can see, 10 inches of water, pretty spot on after having received over 500 times its full-scale pressure. Now let's apply 15 psi. See what happens to the other transducer. And there it is. It reached 15 psi. It's reporting 15 psi. So this transducer also was not affected by the overpressure event. The typical transducer, you can see 27 psi. It actually climbed up some more. So it had been affected, and it continues to be affected when you apply the same overpressure to it, which an overpressure event like that pretty much rendered it useless. We will not be able to recover the calibration on this device. There's not enough adjustment on the 0 and span settings to do so, so it's rendered useless. So there it is. This concludes our experiment, and showing that there are products, transducers on the market that have very high overpressure protection, and that's a very important specification, especially for applications where unintended overpressure can occur, or a system can apply periodically overpressure events which would typically damage a typical pressure transducer if it did not have high overpressure protection. Well, again, thank you for viewing this presentation.